Good evening, everybody. My name is Jayke Norris, and today I'll be presenting on my demonstration speeches. It's going to be about weather and flight planning. So to introduce you guys to our aircraft, this is the PA-28161 Cherokee. So this is a four-seater aircraft, lovely for the four of us. We have a single piston prop, and we also have a low wing structure with fixed gear. So let us introduce ourselves to our flight. So we are planning to go from Fresno to Van Nuys Regional Airport. So we're going to fly down the Central Valley, fly over Bakersfield, over a mountain range that sits roughly about 9,000 to 10,000 feet, down to Burbank, California. You can already see from the lower edge of the screen, the green, we can already anticipate there's going to be some precipitation on our route. So let's go through that. So what causes weather? To briefly explain it, it happens when the sun unevenly heats the Earth's surface, causing a difference in temperature, thus causing a difference in pressure, generates wind, so forth, so forth. But we're going to stick to some of the graphical depictions that we can pick up for this flight. So looking at aviationweather.gov, this is a loft prog chart. This depicts to us what's actually going on outside, kind of like meteorologists, right? So pilots can look at this and interpret the conditions that we can expect with these different phenomena that are going on. So you can notice that there's a yellow dashed line that's nicely following the coast of California. This is a trough or elongated area of low pressure. This means that there is going to be some unstable air. Unstable air has a characteristic to want to rise, and it creates this lifting force that gives a lot of feed to these big puffy clouds that we get out here, right? So that's going to be like cumulonimbus cloud, cumulonimbus, could be nimbus stratus, that kind of thing, but lots of clouds with significant vertical development. And if you have a general representing that there's going to be wind generating from the west blowing to the east, we know that the air mass that this source region is coming from the ocean. So we already can anticipate there's going to be a lot of moisture in this air mass, right? And thus you can see these different colors down here, which is depicting the precipitation that we're going to encounter. So if we overlay this over our route of flight, you can see that it's right in our way. So the different colors tell us some different things. So the green is going to be rain, the lighter green is going to be light, dark green is going to be heavy. We also have this pink color, which is snow, and the blue color is mixed. So we can anticipate a lot of different types of visible moisture throughout our flight. So taking this all in mind is great. We can still fly through rain. Contrary to popular belief, it might be a little bit turbulent, but it's not actually that big a deal. However, we also have to look at the freezing levels, right? So this blue area that you see over Utah, New Mexico, Arizona, and Wyoming is going to be where the freezing level starts at the surface. We're in the white area, so we're good, right? Everything's fine. Actually, we're not. We have to look at those lines. So this one spanning out to the Pacific Ocean says that the freezing level starts at 8,000 feet. And then we also have this one that's kind of in between where California meets Nevada is going to be somewhere around 4,000 feet actually. So anywhere from 4,000 to 8,000 and above that will be above the freezing level, which we are. Remember, we're going at 11,000, so we can anticipate we're going to be in that freezing level. So seeing that we have these two conditions, we know that icing is going to be present. So let's talk about some airframe icing. So airframe icing, a little bit, it's not too dangerous. As it starts to accumulate, our weight's going to increase, right? Maybe it'll increase so much that we're just going to fall out of the sky. It's actually not what happens. I mean, it does. It does increase our weight, but what it's actually doing is, as it accumulates over the wings, it changes the overall wing structure or the surface in which that airflow is going over. So not only is it increasing our weight, but it's also changing aerodynamically. And not only increasing our weight, but significantly increasing our drag. So let's talk about aerodynamics a little bit. So this simulator is going to show you the airflow going over an airfoil, which is a fancy word for wing, but imagine that you're looking on the side of the aircraft here, the side profile of the wing, and this is what's actually going on. So that laminar airflow going over the top is going slightly faster than the airflow going over the bottom. And what this creates is a difference in speed, which also creates a difference in pressure. This plays on Bernoulli's principle, where high pressure always wants to go to low pressure. We have high pressure going along the bottom of that wing, which is depicted here. You can see this little area of low pressure, and that bigger area of high pressure on the top it's pushing up on the bottom of that wing. And this actually gives us our ability to generate lift, right? So yeah. Now we're in flight, and we're flying along, and everything's going fine. We have smooth airflow going over the wings. What you'll start to notice as we cross over those mountains into Burbank is that we might start to pick up some ice. So I want you to pay attention on that front leading edge, or this bigger chambered side, as that ice starts to accumulate. And just notice the airflow is still going smooth. We have a little bit of icing, everything's fine, right? But as it starts to accumulate, you're going to start seeing the separation of that laminar airflow, especially on the top. So those spirals that you see in that airflow is separation, and this is not what we want. At this point, actually, where we have so much separation that we no longer have that coefficient of lift. So at this point, since we have no more lift, yes, our nose starts to dip, and we start to go towards the ground. So what can we do? I mean, you don't want that to happen. We can't get ourselves out of that situation. How do airlines fly through ice? Well, they have different kinds of systems that can either de-ice or prevent ice from happening. So this is just one of the examples. This is called a leading edge boot, and basically it's a rubberized system that goes along the leading edge, pneumatically charged to basically inflate and just knock all that ice off. And that's great as long as you start early, because if you have it accumulate over where none of that black stuff is, it's not going to knock off that ice, and you're still going to have the same problem. But sadly, our little PA-28 Cherokee, we're cheap, we're not millionaires, can't have fancy planes with leading edge boots or anything like that, so we sadly don't have any kind of ice preventing systems. So now we have to take some risk management, right? We definitely shouldn't take this flight, right? So let's break it down, right? So we have icing conditions present without prevention systems, and we're unable to reroute for avoidance. So like we said, 9,000 to 10,000, the least we can do is 11,000, right? And there's no way to go any lower to stay out of that freezing area without going into terrain, which is not a good thing. But since we don't have any kind of icing prevention or anything like that, the FAA, which is the Federal Aviation Administration, is basically has not certified the Cherokee to fly into known icing conditions, or what's known as FEAKY. So now we're going to evaluate our go, no-go decision, even though it's a little bit apparent at this point, right? So we're not going to be legally or safely allowed to take this flight with everything that we have briefed, everything that we have analyzed, forecasted. At this point, with as significant the weather is, it's bound and likely to happen. So in conclusion, I hope that you've learned a little bit about analyzing weather, how airplanes magically lift themselves into the sky, and why it's really important that pilots analyze and do thorough flight planning before executing any kind of flights, especially with passengers. And I hope you've learned that weather planning is critical to aviation safety. Thank you.